I am in the subject name theory of computation. I am today discuss about the topic an algorithm to design finite automata. Abstract theory of a computation is always been an issue for students to understand. This paper present a algorithm which will be simplify the method to design deterministic finite automata that accept strings over input symbol a b having a exactly x number of a and y number of b. Objectives of the research is to make the method of a teaching learning easier, simpler, understandable for students. In this paper, we developed an algorithm to design a finite automata that accepts strings over input symbol a b having exactly x number of a and y number of b. Introduction. Objective of this paper is to develop an algorithm to design a finite automata that accepts strings for input simple a, b having exactly x number of a and y number of a, b. In this paper, flowchart here for the developed algorithm is also given. We will definitely add a level of understanding in this implementation, which is several examples of different string sets are there, which three cases of a discuss under section implementation. Methodology in automata theory, a branch of a theoretical computer science, deterministic finite automatic DFE, also known as a deterministic finite state machine, is a finite state machine that accept reject finite strings of the symbols and only produce a unique computation or of the automation for each input strings. Deterministic refers to a uniqueness of a computation itself of simplest models to capture the finite machines very among the first researchers to introduce a concept similar to finite automation in 1943. A DFA is defined as an abstract mathematical acceptable due to the domestic nature of a DFA. It is implementable in hardware and software for solving various specific problems. For example, a DFA can be a model software that will decide whether or not online user input, such as email address, are valid. Finite automata is a defined a set of a five tuples where a finite non-empty subset non-empty set of states, a finite non-empty set of inputs. State transmission function Q naught is the initial state, where F is the final state. Subset of Q can be represented using either a three approach in a bigger transition graph, transition functions, transition table. Methodology in automata theory, a branch of theoretical computer science, is deterministic finite automation. DFA, also known as a deterministic finite state machine, is a finite state machine that you accept or rejected finite strings of symbols and you only produce a uniqueness computation or error of the automation. For each input strings, deterministic refers to the uniqueness of a non of the computation in such a simplest model, you capture the finite state machines. Pittsburgh, among the first research introduced a concept similar to finite automation in 1943. DFA is defined as abstract mathematical concept, but due to the deterministic nature of it, DFA, it is implementable in hardware and software for solving various specific problems. For example, DFA can model software that is decided whether or not a online user input, such as a email address, are valid. Finite automata is a defined a set of a five tuples where a finite non-empty set of states, a finite non-empty set of inputs. Uh, Q naught is the initial state, F is the set of a final states. Transition graph, transition function, transition table. There are three apples given the below either of the represented can get a graph. Let us discuss about some examples, problems. Design a DFA that yeah accept strings over input symbol A, B having exactly 3 as and 3 of P. Let the resultant DFAM F5 numbers. Q naught is the initial in this figure. Q naught is the initial state and Q44 is final state in this problem. Resultant of the problem F is equal to Q44. Let us discuss another problem. Design a DFA that accepts strings over input symbol A, B having exactly two as if only one of the letters. Resultant DFA is M Q11, Q12, Q13, Q21, Q22, Q23. In this figure, resultant answer is final is Q23. First problem is a starting initial state is Q naught and final state is Q44. Second one, initial is Q naught Q11 and final state is Q23. Conclusion. In this paper, we have developed an efficient algorithm which will generalize the transmission graph of finite automata that accept the strings will over input symbol A B having exactly X number of A and Y number of A B. Algorithm will help easy and accurate design of a transition graph of a finite automata that accept strings over input symbol A B having exactly X number of A and Y number of B. Thank you for everyone.